Today we are going to see stack, the concepts of stack in data structure. Now, what is stack? Stack in data structure is basically a linear type of data structure that is going to follow the last in, first out principle. It is basically allows the insertion, or you can say the deletion operations from one end of the stack data structure that is on top. Implementation of stack can be done by contiguous memory, which is an array, and a non-contiguous memory, which is a linked list. Stack plays a very important role in many of the application. Let's take few examples. If we take an example, real life example, that is stack of books, or you can say a deck of cards, or you can say a pile of bills, then how we can interpret it? This example will allow you to perform certain operations from one end only. Like when you insert and remove new books from the top of the stack, what does it mean? It means insertion and deletion in the stack data structure can be done only from the top of the stack. So what you can do, you can access only the top of the stack at a given point in time. That means either inserting a new element in the stack, which is also termed as push operation, or removing or deleting an element from the stack, which is also termed as the pop operations. So we can rather say that there are three basic operations in a stack in the data structure. What are the operations we have? We have the push operation, we have pop operation, and we have pick operation. To talk about push operation, what does it involve? It involves when a new element is to be added in the stack. Since you have only one end to insert, so a unique element on the top of the stack is inserted. That means it inserts the new element at the top of the stack. Now goes for the pop operation. Here we are trying to remove the element from the stack again, since you have only one end to do, all the top of the stack. So removing an element from the top of the stack, if you want to do, you have to do it from the top. So which is also termed as a pop operation. So basically push operation is inserting a new element in the stack, and when we are talking about pop operation, it is basically removing an element, or you can say removing that element from the stack, from the top of the stack. Now there is another operation. We call it a pick operation. Pick operation is basically refers to the when we are trying to retrieve the topmost element in the stack without removing it from the collection of the data elements. That is, suppose we have full function is there, which is used to check whether or not my stack is empty. Is full empty is also a function which is used to check whether or not the stack is empty. That means either there are two operations, either is full or we have is empty. These are the two operation function calls we have in pick operation. So my is full function is used to check whether or not my stack is empty, and my is empty function is used to check whether or not the stack is empty. Now this is a simple example of stack representation in a data structure. From this picture you can see that the data element is pushed in the stack and the data element is removed from the stack, that is the pop operation. Here the principle that we are following is last in, first out. Now let's try to understand using this picture. What we can see in left side picture, here the push operation is involved, which involves inserting a new element in the stack. Since you have only one end to insert a new element. It is done on the top of the stack. So it inserts a new element at the top of the stack, that is 400. So first 100 is given, then 200, then 300, and then we are pushing the fourth element. We call it a fourth element, and that is pushed. So what is my topmost element? My topmost element is 400, which is the last one to be inserted. Next, if you look into the right side of the big figure in the slide, you can see the pop operation. What is it? In this, pop operation refers to remove the element. So we can see from the picture that here the top element was 400. So we need to remove 400. So what we are doing over here, we are removing the element from the stack again. Since you have only one end to remove to do it, so we have to do it from the top of the stack. So removing an element from the top of the stack is termed as pop operation. So this we can see in the right side of the picture. Now we will try to understand the working of stack in data structure. Now how it is done. See, from the picture you can see that you have a stack of books. Let's consider you have a stack of books. So you can only see the top, that is topmost book. So the topmost book is namely, you can say 40, which is kept on the top of the stack. Now if you want to insert a new book first, that is if you name it 50, you can update the top and then insert a new text that you can see it in the figure of the slide. So if you want to access any other book other than the topmost book, that is 40, as you can see in the slide, you first remove the topmost book from the stack, and then the top will point to the next topmost book. Okay, so after working on the representation of the stack of the data structure, you can easily understand the basic functions, that is push and pop function, and also the pick function that is performed on the stack in case of a data structure. Now we can go for the next slide, which says that implementation of a stack that is done using an array data structure. What we do here, we can perform the implementation of the stack in data structure using the two data structures, that are an array and a linked list. So what's an array? It's in array. If you want to implement stack, what we do, the stack is formed using an array. Over here you can see it. Here all the operations that are performed will be using the array. So you will see how all the operations can be implemented in the stack data structure. You can see it in the from the slide, from the picture, that first element is 100, second 200, next is 300. So in sequential order my elements are being stored. Next we have the linked list implementation. What happens in the linked list? That means a newly inserted element is pointed to the top. So whenever we want to remove the element from the stack, we need to remove the node that is indicated by the top. So what we can do, we are by moving the top to its previous node in the list, that we can see in the figure. So these are the operations that we have in stack, that is pick, pop, push, pick operations, and also we can do it using we can implement that both using a array as well as a linked list. What is the basic application? Why we need this kind of stack in data structure? So the first and foremost, when we are expressing evaluation and conversation. For example, infix expression is there, prefix expressions is there. What is infix expression? Infix expression is when a single letter on an operator is preceded by a one cell infix string, which can be followed by another single infix string. Same, we have a prefix expression, where in a prefix expression we have a expression there is a single letter or an operator which is followed by two other prefix t. So this is what is there in expression evaluation and confusion. Next we have an application is backtracking. So what is backtracking? Backtracking is a recursive algorithm mechanism which is used to solve generally optimization problems. That is, to solve this optimization problem, what we have to do, we have multiple solutions. That is, it does not matter if it is correct or not, but we have n number of solutions. So while finding all the possible solutions in backtracking, we can store the previously calculated problems in the stack and use that solution in the next one to resolve the following issues. Okay, then we have the function call. Whenever you call one function from another function in a programming, the reference of calling the function that is stored in the stack. So when the function call is terminated, what will happen? The program control moves back to the function call with the help of references that are stored in the stack. So we can see that stack plays a very, very important role when you call a function from another function. So function call is a very important application of stack in data structure. Then we have parenthesis checking. What is this? Stack in data structure is used for parenthesis. Parenthesis means the curly brackets, the brackets we are having. They are valid or not in programming while matching, of opening and closing of the brackets. That is balancing of the brackets. Sometimes we miss out. So this parenthesis checking is very, very important in case of stack. So it stores all these parentheses in the stack and it will control the flow of the program. Okay, so if a single bracket is missing, it will show invalid. So this is again a very important application of stack in programming. Then we have a string reversal. A very another exciting application is this. Why? Because each character of the string is stored in the stack. Okay, so if you talk about the first character in the string is held by the bottom of the stack and of the stack, whereas the last character of the string is held at the top of the stack. So what will be the result? The result is a reverse string after performing the pop operation. So if you do the pop operation, then it will get reversed. So this is another important application. Then we have syntax parsing. What is this? In many of the programming language, we will see the context-free languages are there. That is what the stack is used for syntax parsing for the compilers. Then we have memory management. Sometimes the stack is heavily used to manage the memory. So these are the following applications of stack in data structure. We have a lot of advantages also. What are the advantages? It helps us to manage the data. How? By using the principle last in, first out method. Sometimes the variable is not used outside the function in any of the program. So then we can say that we can use the stack. It also allows to control and handle the memory allocation as well as the deallocations. So it will automatically clean up what the result is, it will automatically clean up the objects. Then there are certain limitations of the stack also. It is really very difficult in stack to create object. Why? Because it creates the risk of stack overflow. The stack over is a very important limitation of stack in data structure. And also because why? Because it has got a very limited memory. So in stack, basically random access is not possible. So this is what we had for stack in data structure.